pretty blues in the side over there. And I come over here and we see black. Right? When we first got off the bridge, we saw black ice as well. When we think about glaciers, we kind of think about blue ice, not black ice. Well, blue ice is actually only in the top 300 feet of glacial ice. Blue ice is still technically compressed snow. So it's made up of billions of ice crystals that have a lot of facets to refract light, and water naturally absorbs red and green and refracts blue. So that's why we see blue in the top 300 feet. Now, all of this ice is formed by the pressure of snow falling on top of snow. So the deeper we get, the more pressure it's under, therefore the denser it gets, right? Ultimately, what's happening through that whole process, you're compressing oxygen out of the ice with all of that pressure. You cannot compress water, but you can compress oxygen out of water. So the deeper we get into the ice, the less oxygenated it gets. Now at the 300-foot depth, that's where we actually have enough pressure built up to create a molecular bond between all of the ice crystals that make up the ice. Therefore it becomes one singular solid, completely clear, right? But as we get deeper, it gets under-oxygenated. Under-oxygenated ice actually absorbs that at a very rapid rate. So if we chipped off a 1-inch piece of this, it would look completely clear like a window pane. But if you chipped off a 6 to 8-inch piece, it would actually look like you're looking through tinted glass. That's how much light it can absorb through a very short period of space. It's pretty incredible how dense this ice is. Now, other than being black, the ice that's below 300 foot, when it's under pressure, this is exposed, doesn't have at least 300 foot of ice on top of it, but when it did, it was in what's known as a plasticized state. Plasticized ice is number one, too dense to fracture or crack anymore. So when we look out behind us, we see all the big fractures in the ice known as crevasses and seracs, which we'll talk more about later. You'll actually never find one of those features on any piece of ice anywhere in the world that's deeper than 300 feet. It is physically impossible. Because plasticized ice actually flows like honey or molasses. So literally the way the glacier makes its way down the valley is you have the top 300 feet of blue ice. That's known as our brittle layers of ice. That is literally riding on a frozen river of all of the black or basal ice that's down below. So that with the help of gravity, we're coming from 13,000 feet down to 1,400 feet, and a little bit of lubrication. There's always about 2 inches of water flowing underneath the glacier. Now that water's under so much pressure, it flows at super cool temperatures, usually right around 24 or 25 degrees. But that's how the glacier makes its way down the valley. So contrary to what most people think, it's not just a big chunk of ice sliding down a valley. It is literally a frozen river flowing down a valley. It's pretty incredible, isn't it? Now, I talked a little